Hello, accounting scholars. Hey, it's Monday and we've got a freeze day. Hope you're enjoying it. Hey, we're going to jump back on to these inventory related questions. You know, inventory might appear to be a relatively boring subject to talk about. On the other hand, if you're an owner of a retail business, it's probably one of the most critical decisions that you make. Because if you have too little inventory, as we talked about in our earlier uh, videos, you lose customers if you don't have the products they want when they want them. On the other hand, if you have too much inventory, as we're going to talk about here, uh, you incur costs as well. You first of all, let's say if you have a retail store, you have to buy inventory, uh, and there's could be significant costs associated with holding that inventory. Take for example, if you were a smartphone, cell phone store. If you were going to be buying 100 to 200 Samsung Galaxy smartphones uh, to sell to your customers, that could be quite expensive. And if you don't sell those for a significant period of time, you have a lot of money tied up in inventory. So that's one of the reasons for not holding inventory. The other part of having inventory is sorry about those dogs. Is that it allows you, if you have a lot of inventory, to hide problems with your business. In a lot of inventory is just like overeating. You tend to get sloppy. You tend to get fat. Your business tends to get fat, and as a result, it's not being run as efficiently as it possibly could be. So, two major problems with or reasons for not holding a lot of inventory. One, the cost associated with it, of holding it and purchasing it, and then secondly, it just allows you to get sloppy as a business. Uh, in the next area we're going to talk about is, okay, so how do I optimize or most efficiently address the handling of inventory? And there's two basic strategies here. One is quite famous. It's called the EOQ, or economic order quantity, and the other one is the JIT, or just in time approach to inventory. Now, the EOQ, economic order quantity, is essentially a model that is short term in its focus, and it minimizes or reduces the incremental ordering and carrying costs. And you might say, oh, Mr. Sean, what are you talking about? What do you mean incremental ordering or carrying costs? Well, whenever you're dealing with inventory, there are specific costs associated with it. For instance, if you were that Samsung dealer that we were talking about, every time you would place an order, there would be ordering costs associated with it. There's paperwork costs, tracking costs that you get involved. People have to place orders, they have to track the orders, and then there's the actual shipping costs. In terms of if a product is being shipped from LA to Chicago, you're likely paying for those shipping costs either directly or indirectly. Those would be considered incremental ordering costs. On the other hand, there's carrying costs. If you have a lot of inventory, you're going to have costs of having it in stock, and that has to do with as simple things as if you have something on the shelf, somebody might steal it, right? Pilfering costs, that's a cost of carrying inventory. Other costs are actually the investment in cash that you have in there. So in EOQ, economic order quantity, the model minimizes those particular costs. Now, on the other hand, the just-in-time approach is a longer-term model which assumes that you can reduce or minimize product sustaining or facility sustaining costs that are relevant by using this approach. And when you look at this particular example on the slide, it becomes clear. What they're demonstrating here is exactly what the just-in-time model is. And basically that says you do not receive inventory until you're ready to either begin the production part that uses that inventory or actually sell it to a customer. And in this case, there is actually a production phase prior to the sales phase. So you see the delivery man actually bringing a box of inventory directly to the line when they need it. That is where the just-in-time concept comes from. And as you see, that inventory moves through the production process relatively quickly, and then it's actually comes off the line and is immediately sold to the customer. So the concept of just-in-time inventory management. Now, there actually is a model which is used for this particular approach, and it's called the EOQ model. We're gonna go through that on the next slide, but let's take an example here, and we're going to use some terms that you're familiar with and some terms that you may not be familiar with, but we'll kind of walk through them here. And make sure you take some good notes here, because you're probably going to see these types of problems on quizzes, tests, and on your final. So a company estimates that its annual demand, that means the number of units that it actually produces and sells, is 67,500 units. As we talked about, companies track how much it costs to place an order. And the cost to place an order is about $8 per unit. And then there are costs to carry the inventory, to actually hold it in inventory. And in that particular case, that represents about 75 cents per unit. So then the question becomes, what is the number of days that the company actually operates? And in this case, it's 300 days. And it would like a safety stock of 100 units. By safety stock, meaning that it never wants to have less than 100 units in inventory because it wants to make sure that it will never run out and it will never lose a sale because it doesn't have a unit, so units in inventory. So that is called a safety stock. It's 100 in this particular case. Now the other factor is, how long does it take to order inventory? What is the delivery cycle? And in this case, the delivery cycle or lead time is 2 days. So the question then becomes, what is the EOQ, as we talked about in the previous slide, or the reorder point? Well, let's do the math here. The EOQ equation is demonstrated at the top here. It equals the square root of 2 times the annual demand times the incremental ordering cost. And that is divided by the incremental carrying cost. So that's the equation. And as you see here, if you do the math, 2 times the annual demand, which is in this case from the word problem in the previous slide, is 67,500, times the incremental ordering cost, which is $8, and then divided by the incremental carrying cost, which is 0.75 or 75 cents. You do the math there, you take the square root of that answer, and you come up with an economic ordering quantity of approximately 1,200 units, which basically means when you place an order, you should be placing an order for approximately 1,200 units on your particular vendor. If it was Samsung, you'd be placing an order for 1,200 Samsung Galaxy phones. Now the question is, what is the reorder point? Well, the equation for the reorder point is annual demand divided by days operating per year times lead time plus safety stock. So here again, we're just going to plug in the numbers. We know the annual demand is 67,500 units. We divide that by the days operating per year, which is 300, times the lead time of 2 days, plus the safety stock of 100, and we come up with a 550 reorder point. All right, guys. So we're gonna cap it here. Please take good notes, especially on these equations, and we will see you tomorrow in class.